The diagram shows part of the curve with equation y equals 5x over 4x cubed plus 1. Part A, we need to find dy dx and the x coordinate of the maximum point. So this is the maximum point here. At this maximum point, dy dx is 0. First, we need to find dy dx. Since y is a quotient, then we need to apply the quotient rule. So we hold the denominator, which is 4x cubed plus 1. Differentiate the numerator, we get a 5. Now we hold the numerator, which is 5x, and differentiate the denominator, which is 12x squared. And all this is divided by the square of the denominator. We simplify the numerator. 5 times 4x cubed, that will give us 20x cubed plus 5 minus 60x cubed. We always keep the denominator when applying the quotient rule. The denominator must not be expanded. So this gives us negative 40x cubed plus 5 all over the denominator. Okay. That gives us dy dx. The second part of part A is to find the x coordinate of the maximum point. Maximum point occurs when dy dx is 0. So we set dy dx to 0. Negative 40x cubed plus 5 all over 4x cubed plus 1 squared equals 0. The numerator must be 0. The denominator can never be 0. When we set the numerator to 0, negative 40x cubed plus 5 equals 0, so that 40x cubed is negative 5. And then this will give us x cubed. Oh, sorry, this is positive 5, not negative 5. So it should be negative 40x cubed equals negative 5. Never mind about that. Then x cubed is 5 over 40, which is 1 over 8. Taking cube roots, we have x equals 1 over 2. That is what we want for part A. Part B, we need to use the trapezium rule with 2 intervals to find an approximation to the area of the shaded region. Your answer must be correct to 2 significant figures. For part B, for 2 intervals, so this is the second interval. This occurs when x is 2. Now we need to find the y value. We have 1, so we replace x with 1 into y, and we have a y coordinate of 5. The second point here, x coordinate is 2. Then we replace x with 2, and we have 10 over 33 for y. And for the third point, x is 3. When we replace x with 3, y is 15 over 109. Then we look at the y coordinates, and then we apply the trapezium rule. So these are the y coordinates that we need to look at. To apply the trapezium rule, the area is approximately 1/2 of the width, which is 1. Then we take the y coordinate of the first point, the height, 5 plus 2 times the height of the second point, which is 10 over 33. And we add to the height of the third point, which is 109. And we get a value of 0.87. Part C, state with a reason whether your answer is an overestimate or underestimate. To see whether it's an overestimate or underestimate, join these 2 points to form a trapezium, and then you join the other 2 points to form a trapezium. So for both cases, you can see that the trapezium or the curve is below the top part of the trapezium. Since the curve is below the top part of the trapezium, then the trapezoidal rule will give us an overestimate.